Section 1.3, we are going to talk about the midpoint and distance formula. So what you should be doing right now, writing midpoint formula off to the side in your notes. And don't work ahead, but we're going to write this formula down together. So midpoint is denoted by a capital M. Okay, so we're given 2 points and you want to find the midpoint. You're going to use this formula. You take x1 plus x2 divided by 2. And then y1 plus y2 divided by 2. And we're going to break this down a little bit. So what I want to ask is what mathematically is happening right here. For example, if I take 2 things and I divide by 2. Or if I take 5 things and I divide by 5.
You're splitting it.
What'd you say? Close. If we divide by 2, yes. But we are taking the average. Okay? Right here, this is the average of the x values. Okay, what's happening over here? Average of the y values, yep. Exactly. So, remember to find the midpoint, we're talking about 2 different points here. So, if I have point P, I'm going to label that as my x1, y1. Why do you think I have 1s right here?
Because there's one of them.
Yeah, Braylon.
Because there's going to be another set of coordinates that are going to be different numbers than those.
Exactly. So these 1s, those just stand for the first coordinate. Okay. So then what do you think the x2, y2 is? Second coordinate, exactly. Okay. One more thing I want to talk about is the notation. Does anyone know what I mean by notation? It's how something's written. Okay, so is this answer just going to be a numerical answer?
Yeah.
What I mean by that, am I just going to get like, okay, the answer's 5? No, what's my answer going to look like? So say it out loud. Someone said it. It's going to look like a coordinate. Okay, your answer is going to look like some xy coordinate. Okay, because we're looking for the middle of 2 points. Okay, so try this formula with this specific line right here. So what you should write down, since you don't have this, is our A coordinate is -3, 2. Our B coordinate is 4, -2. We want to find the midpoint. What I want us to get in the habit of is a little process to follow. Okay, so first thing I always want you to do whenever you're given a formula is I want you to label what you need. So remember, for midpoint, we need that x1, x2, and we need the y1, y2. Okay, so what could I label? I'm going to say A. What could I label A coordinate? x1,
X2.
y1. Why did I label it x1, y1?
Because that's where you have to put it in the formula.
Right, and that's our first coordinate, right? So remember those subscripts mean? That's our first coordinate. So what can I label coordinate B?
X2, or Y2.
X2, Y2. Okay. Am I ever going to have X1 and Y2 together? No, those are 2 different coordinates. Okay, so now that I have it labeled, it's easier for me to take it and plug it into the formula. So following the formula, what's x1?
-3.
-3 plus
4.
x2 is 4 divided by 2. What's y1?
2.
2 plus
-2.
a -2 divided by 2. Biggest thing I want to see when you do these problems, I want to see the labeling and I want to see how you plugged it in. Okay, if you want to do the rest of it in one step, that's fine. I'm going to keep going in separate steps.
Do we have to label it?
Yes,
And Y.
for now. I'll explain in a second. What I mean by label is this. Yep. So, continuing on, what's -3 plus 4?
1.
1. And then we have divided by 2. What's 2 plus a -2?
0.
0 divided by 2. Now you want to make sure your answers are in simplest form. I do not care if you leave it as a fraction or if you write it as a decimal. Okay, so I'm going to leave it as 1/2, but what could you write it as? You could also have it as 0.5. Okay, can I leave this as 0 divided by 2? No, what should it be? Right, 0 divided by 2 is 0. So I would accept either of these. Okay, I'm just going to leave mine in fraction form.
Do you have to write the equal sign?
I'm not going to be picky about that, no. Nope. Back up here, what do we need to do first on part A? Label. What can we label C? X1, Y1, D?
X2, Y2.
X2, Y2. So using the midpoint formula, what is X1? Negative 2 plus?
8.
Yep, divided by? 2, good. What's next? 5 plus? Negative 12 divided by? 2, awesome. Here, what's negative 2 plus 8? 6. And then 5 plus negative 12? Negative 7. Can I leave it like that?
No.
Nope. 6 divided by 2? 3. What about this guy?
You can leave it.
I can leave that or go for it right as a decimal. So if you had this as a negative 3.5, that's cool too. Clap once if you agree. All right. Part B, what do we got? What do I do first?
You plug them in to the formula.
Label. Why did some of you say labeling makes it so much easier?
It is.
Why?
You can like mix and match and pair them.
Right. If you already have them labeled, it makes plugging it into the formula so much easier. Okay? So what do I add together here? 2.5 plus, remember we're adding that negative. Are negatives important? Sure are. What about the y's? Exactly. Divided by 2 equals, what did I get? You can tell me your final answer because I know that's what most of you have.
Negative 1.85.
Negative 1.85?
Negative 5.4.
Negative 5.4. Again, do I expect you to do mental math? No. Clap once if you agree. Awesome. So we have distance formula moving on next. So go ahead and write this off to the side of your notes. Okay? And we're going to rewrite this together. So distance formula is notated or labeled with a lowercase d. Okay? And then we have the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay? Go ahead and write that down for me. All right, what are some similarities that you talked about with your group between the midpoint and distance formula? Go for it.
So you're both square. Oh, similarities between each form, like different formulas?
Between the two formulas,
You
yep.
square both of them.
Ronan.
The x coordinates and y coordinates are used in the similar ways.
Right, they're together. The x's are together and the y's are together. Awesome. Any other similarities? All right, let's move to differences. Brecken.
Oh, I have one more similarity.
All right, go for it.
There was x1 and x2 and y1 and y2.
Bingo. Yep. What about differences?
You're
Kenzie.
subtracting x1 and x2 and y1 and y2 in the distance formula, but in the other one you're adding.
Right. This is the big difference right here. We are subtracting the x's now, and we're subtracting the y's. Okay. Before we were finding the average and we were adding them together. Brecken.
There's a d instead of an m.
Ronan.
It's all being square rooted.
Yeah, we have a big square root that we have to take care of. Okay, was that what you were going to say? Yeah. Yep. So what I want us to do is I'm going to give us two coordinates. I do want you to write this off to the side. Okay, so if I said A is negative 5, 2, and B is 1, 3. Okay, let's go through how to do this. I still want you to label. So what should we label A?
x1 and y1.
X1, Y1. What about B?
X2, Y2.
X2, Y2. So we're plugging in values here. What do I write first? What's X1? Negative 5 minus 1. Hey, tell you what, I'm going to put this 3 as a negative 3 for me, just so I can talk about something. Squared plus, what's Y1?
2.
2 minus?
3.
Yep, I switched it. Make that a negative 3 so I can talk about something quick. Okay? So, now we keep going. What's negative 5 minus 1?
Negative 6.
Negative 6 squared plus What happens right here?
Plus.
Yep, turns into addition. What's 2 plus 3?
5.
5 squared. Okay, something I want to talk about. I want everyone to type in their calculator right now, -6 squared. -6 squared. What should we get? What is -6 squared?
I don't know how to do that on my calculator.
-36.
It should be positive 36, but what are some are you getting? Are some of you getting a -36? Right. Can calculators be wrong?
Yeah.
Why are calculators wrong?
Because there's multiple things.
Because it's not.
Operator error. Okay, the operator, the user is what's wrong. Okay, if you are ever using negatives, you need to put parentheses around that. Okay, so we know this should be a positive 36 plus what's 5 squared?
25.
25. What should we do from here? We got to add them together first. What's 36 plus 25?
61.
61. Now, if you square root that, what is the square root of 61?
7.81024.
All right, this is all I need. Whenever we have decimals, I want you to get used to rounding to the nearest tenth. How many decimal places is that?
2.
Tenth is 1. Okay. So if I want 1 decimal place, remember if this is lower than 5, what happens to this? It stays. Yep, so we're left with a 7.8. Okay. So with the distance formula, is there a little bit more going on here? Yes. Okay, biggest thing, be careful with negatives. That's the biggest mistake people make is the negatives. Okay, watch out for negatives. All right. Moving to this example here. We need to do a little graphing review quick. So, for example, if I'm looking at this shortstop, what are the shortstop's coordinates?
5, 10.
5, 10. In your groups, go ahead and find the other 3. Go. All right. What did you guys get for the pitcher? I heard 5, 5. Clap once if you agree with 5, 5. What about the batter?
0.
Clap if you agree. And first baseman. Did anyone say 0, 10?
No, we did not.
Okay, it should be 10, 0. Clap if you agree. All right. Can someone read me the directions to your example 4? Sam, go for it.
How far does a shortstop need to throw the ball to reach the first baseman? Round to the nearest tenth of a foot.
Okay. If it's asking how far between 2 points, they're asking for the distance. Okay, so what should you do when you're trying to find the distance between the shortstop and the first baseman?
Pythagorean theorem.
Use the distance formula. Now, so on example 4, I want you to find the distance between the shortstop and the first baseman in your groups. Go. All right, so we are using the shortstop and the first baseman as our coordinates. So what can I label shortstop?
Shortstop.
S.
This is what I was getting at. Yep, x1, y1. What about first baseman?
x2, y2.
x2, y2. So using the distance formula, what is my x1 minus x2?
5 minus 10.
5 minus 10 squared plus
10 minus 0.
10 minus 0
Squared.
squared. What is 5 minus 10?
Negative 5.
Negative 5 squared plus
10 squared.
10 squared. What is negative 5 squared?
25.
Is it negative 25? No, positive 25 plus 10 squared.
100.
100. What do we do next? 125. Is this my answer?
No, you gotta square root it.
Gotta take the square root. What is the square root of 125?
11.2.
Yep. Clap once if you agree with 11.2. Awesome. Okay. All right. Number 2, error analysis. It says Khalil calculated the midpoint with those coordinates. What did he do wrong? Anybody want to share? Keaton.
You put the x's and y's together instead of putting x1 and x2 together.
No.
You have the right idea, but you said it wrong.
I got it.
Ah.
Ronan.
He added X1 and Y1 and X2 and Y2.
Correct.
The two X's and 2 Y's.
Correct. You were trying to say that. You just said it wrong.
That's what I said.
Yep. So, what should these two values be?
-3 and 1.
Those should be your x values, right? So these should be your -3 plus 1. What should these values be?
Your Y.
Those should be the y values, which in this case are 5 and 7. All right, number 4. Is it possible for a line to have two distinct midpoints?
No.
First of all, what does distinct mean?
Same.
No.
It's spot on.
Distinct means different. So is it possible for a line to have two different midpoints?
Yes.
No.
Absolutely not. Okay?
They wouldn't both be.
It would not be in the middle. Okay? Also, if you and your friend chose like different coordinates, like if one chose this as the first coordinate, one chose the other as the first coordinate, should you still get the same answer?
Yes.
Yes. Okay, so there's only one midpoint. All right. For these that we're going to end up going over tomorrow, I want you to do number 5. Do number 5, circle that. And I want you to find do number 7.
Could we do 6 and
Nope.
7?
On number 7, it's asking it a little different, but what's another word for length? Distance. Yep. So you are doing the midpoint and distance formula for the 2 points up at the top. We will go over these tomorrow.